So this part of section 3 deals with what we call end behavior. End behavior is how the function behaves at the end of the graphs. So either at positive infinity or x equals negative infinity. So normally when we deal with graphs in math, we're always, sort of like just focused here, right? Usually x is like 2 or -1 or 3, or, sometimes it'll get, we'll get a really big number like x equals 20, right? But for end behavior, we're going outside of that all the way here, and we're dealing with what happens to the graph when x is infinitely large, like 1,000,000, 1,000,000,000, 1,000,000,000,000, and so on, or in the negatives, what happens when x is -1,000,000, -1,000,000,000, -1,000,000,000,000. So as you can see with this graph, and what I like to do is I like to trace the graph when I'm doing this with my pencil or my finger or so on. So as x approaches positive infinity, as you go towards the far, far, far right of the graph, what is the graph doing? Or more importantly, what is happening to the y values of the graph? So you can see here at the very ends, the y values are dropping down, down, down towards negative infinity. So we say the limit of f of x as x approaches infinity is negative infinity. Now, on the other side, on the left side, this is going to be the limit of f of x as x approaches negative infinity. Now the x's are going to be negative 1,000,000, 1,000,000,000, and so on. Well, what happens to the graph there? As you go to the far right of the graph, you see that the y values are climbing up, 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 up to positive infinity. Okay? So that's end behavior. Basically, how is the graph behaving at the very right or at the very left? So when we talk about right end behavior, that's the limit as x approaches positive infinity to the right. When we talk about left end behavior, that's the limit when x approaches negative infinity to the left. Okay, so let's take a look at this. We want to describe the end behavior by looking at the graph. Okay, we're always going to look at the graph to describe end behavior. So when you're told to describe end behavior, you're going to provide two answers: the limit as x approaches infinity and the limit of f of x as x approaches negative infinity. Now, as x approaches positive infinity, again, you want to trace the graph and see what happens at the far right. At the far right, I mean like at the ends of the grid. At the ends of the grid, what's happening to the y values? Do you see how it looks like it's flattening out at y equals 0? So I say the limit is 0. And what about as x approaches negative infinity? At the far left of the graph, what's happening to the y values? Well, it looks like the y values are flattening out again at y equals 0. So that is how we answer this question. And now somebody might be asking, well, wait, you didn't even look at this. Well, yeah, because what are the x values here? 1, 2, -1, -2. That's not what we're concerned with end behavior. We're concerned with x equals 100, 1,000,000, -1,000,000, okay? All right, so here again, we want end behavior. So limit of f of x as x approaches infinity. Limit of f of x as x approaches negative infinity. Well, here, as I go to the far right, what's happening to the y values? They're climbing up, up, up to positive infinity. What's happening to the far left? They're climbing down, down, down to negative infinity. And that's it. Okay, that's how long it really should take. Okay, now for these, I don't have the graph given to me. So what I'm going to do is I'm going to graph the functions myself. So let's go ahead and do that. So I graphed the first function. All right. So if I go into tab, up, there's the function. And now when I take a look at the graph, this is what it looks like. All right. And so it says, is there a discontinuity and a type? So you look here. All right, you look here. Are there any breaks in the graph? Are there any vertical asymptotes in the graph? No, there are not. So I say none. There are no breaks, no gaps, no holes in the graph. It is just a smooth function. You can graph the whole thing without taking off your pencil from the paper. All right, that's how you know it's continuous. Okay, right end behavior. The limit as x approaches positive infinity. As we go to the far right, the graph is going up, up, up to infinity. As we go to the far left, the graph is going down, down, down to negative infinity. Now for the zeros, I go to Menu, Trace, Graph Trace. And here, if you keep pressing the left or right arrows, don't do it too quickly because you'll miss it. At one point, you'll get to a point where it gives you 0. And you see here -2, 0. So x equals -2 is one of the zeros. Now I'm going to go to the other zeros. So press right, right, right. Don't go too fast. You'll miss it. Right there, x equals 1. There's another one. Whoops, I missed it. Right there, x equals 2. All right. Now let's put in the next graph. Tab, press the up arrow. To delete this, all I need to do is do Control Delete. I need to put parentheses around the numerator for this one. So parenthesis, x squared plus 3x minus 5 divided by x cubed. X squared plus 3x minus 5 divided by x cubed. Enter. And I want to make sure that it looks like how, it looks on the paper, right? Which it does. The function here looks like how it looks on my paper. Okay, so discontinuity on type. Do you see that there is clearly a break here, a vertical asymptote, an infinite discontinuity at x equals 0? We could have also known that just by looking at the denominator, because remember, if you have something in the denominator, you can set it equal to 0, and x equals 0 is where you have a discontinuity. Since x cubed can't cancel with anything in the top, that's an infinite discontinuity. Okay, you can see it also as a vertical asymptote on the graph. Okay, right end behavior. As you go to the far right, we see that the graph is leveling off, evening out, flattening out at x equals 0. To the far left, it's flattening out at x equals 0 again. Okay, what about zeros? Let's trace. So I'm going to go to the left, 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 left. Right there, there's a 0 at 1.19. And then let's go right to the left again. Keep doing it. It's going to go really down, like far down, and then it's going to come back. So look, it's going way down, but then it'll come back up from the top. So just keep doing it. Don't go too fast so you don't miss it. Right there, it looks like I'm going to hit a 0 soon. Right there. So at -4.19. Okay, and there you have it. That's the end of section 3. Thank you.